sklearn. Neighbors. Radius neighbors transformer. Description. The radius neighbors transformer is a class in scikit-learn that transforms data by replacing each sample with its k nearest neighbors within a specified radius. It's useful for imputing missing values, denoising, and creating a smoother representation of the data. Inputs. X. This is the input data. Typically a 2D array where each row represents a sample and each column represents a feature. Radius. This parameter defines the radius around each sample within which to consider neighbors. It controls the locality of the transformation. Outputs. Transformed X. This is the output data. A 2D array with the same dimensions as X, where each sample has been replaced by the average of its neighbors within the specified radius. Neighbors indices. This is a 2D array where each element contains the indices of the neighbors for the corresponding sample in X. Steps. 1. Find neighbors for each sample in X. The algorithm searches for all other samples within a specified radius. 2. Calculate weighted average. The transformed value for each sample is computed as a weighted average of its neighbors within the radius. The weights can be uniform equal weight for all neighbors or based on distance closer neighbors have higher weights. Metrics. Mean squared error MSE. This metric measures the average squared difference between the original and transformed data points. It can be used to evaluate the performance of the radius neighbors transformer in terms of data reconstruction. Root mean squared error RMSE. This is the square root of the MSE and provides a more interpretable measure of the average difference between the original and transformed data. Visualization plots. Scatter plot. A scatter plot can visualize the original data and the transformed data, showing how the radius neighbors transformer modifies the data points. Fine-tune parameters. Radius. This is the most important parameter to tune. A larger radius will include more neighbors and result in a smoother transformation. A smaller radius will focus on local neighborhoods and potentially preserve more detail in the data. Metric. This parameter controls the distance metric used to find neighbors. Different metrics can be suitable for different data types and applications. Common options include Euclidean, Manhattan, and cosine. Weights. This parameter specifies the weighing scheme used for calculating the weighted average of neighbors. Uniform assigns equal weights to all neighbors. Distance assigns weights inversely proportional to the distance from the target sample. Uncertainty methods. Confidence intervals. Confidence intervals can be estimated for the transformed data based on uncertainty in the neighbor selection process. Challenges and fixes. Challenge 1. Sparse data. When data is sparse, finding neighbors within a fixed radius can be challenging. This can lead to inaccurate transformation results. Sample use case that resulted in challenge 1. A dataset with many missing values or a dataset with high dimensionality can be considered sparse. Fixes to challenge 1. Consider using a different distance metric that is more appropriate for sparse data, such as the Jacquard distance. Experiment with different radius values to find an appropriate balance between finding enough neighbors and avoiding overfitting. Challenge 2. High dimensional data. Finding neighbors in high dimensional space can be computationally expensive and might result in poor performance. Sample use case that resulted in challenge 2. A dataset with hundreds or thousands of features could lead to this challenge. Fixes to challenge 2. Consider using dimensionality reduction techniques, such as PCA, before applying the radius neighbors transformer. Choose a distance metric that is robust to high dimensionality, such as the cosine distance. Challenge 3. Outlier detection. Outliers can significantly affect the transformation process. If a single outlier is within the radius of a sample, it can heavily influence the transformed value. Sample use case that resulted in Challenge 3: a dataset with a few extremely unusual samples could lead to this problem. Fixes to Challenge 3: pre-process the data to remove or handle outliers before using the radius neighbors transformer. Use outlier robust distance metrics or weighing schemes to mitigate the influence of outliers.